Hi, my name is Manish Gupta, and in this video number 205, I'm going to talk about Chameleon, which is a plug-and-play compositional reasoning framework for large language models. So let's understand how does Chameleon work. Well, Chameleon essentially is large language models combined with plug-and-play modules for compositional reasoning. Okay, the idea is that large language models, although they have been, very popular, ChatGPT, GPT-4, everyone knows them, but they also lack some skills. For example, they cannot understand really well from images. They cannot do certain kinds of reasoning and so on. So it's always nice to basically augment their capabilities using external tools. And Chameleon essentially is one of those frameworks which tries to do this by bringing in a planner which synthesizes programs to compose over various tools. So Chameleon actually comes with a toolbox, and then there is this planner. Planner is basically just an LLM prompt, of course, right? Which basically takes the definition of these tools and the current task, and then comes up with a plan, with a sequence of tools to be used so as to solve the problem. That's it, right? So, for example, here there are three different tasks which are being shown from a data set called as science question answering, ScienceQA. Okay. So here is the first task. What is the direction of this push? So there is a picture, and this guy is basically, pushing the ball away using the baseball bat. And the question is, what is the direction of this push? There are two options: away from the baseball bat and towards the baseball bat. And the planner sort of decides that, hey, it is a good idea to use these kinds of tools: image captioner, knowledge retrieval, solution generator, and then finally come up with the answer. Okay. The image captioner, of course, is going to use you take the image and caption, generate a good caption. Knowledge retrieval is basically going to find other similar knowledge pieces from some corpus. So, for example, figuring out that, hey, what is baseball bat and what is push and so on, right? Solution generator is basically like a decoder. So essentially, it's just going to combine all the knowledge that has been extracted, retrieved by the knowledge retriever, and the caption from the image, and possibly the image and the question and the answer options, all of them, so as to generate a nice solution text. And then answer generator is really a rule-based system, or a rule-based module which just tries to figure out the right answer given the kind of task. Okay. So that's that. Second example is actually shown in more detail. So for example, here is an image, and it has certain some basically things in the image, some picture, and then there is also text written in the image. And then the question is, what is the main persuasive appeal used in this ad? And there are three options available. Okay. Now, of course, to be able to solve this problem, what you need is certain kinds of things like OCR, so which is done using text detector. Then you need knowledge retriever. So by the way, the text detector actually retrieves this text. So this is what is basically written on this image. So earthy paper plates now, carry the Sierra Club seal of approval. Okay, so it's basically showing that yes, there is some credibility, seal of approval is there. Okay. So knowledge retriever is basically going to retrieve knowledge. So essentially, it's going to get all of these different knowledge pieces. What is persuasive? So basically, what is the question all about? Then there are three types of persuasive appeal: ethos, pathos, and logos. Denoting those, right? And then it's basically going to get definitions of all of those. Okay. Now, solution generator basically takes all of these. So, by the way, modules in the pipeline, the next few modules in the pipeline basically make use of the outputs of the previous few modules. Okay. So the solution generator is going to take all of this stuff, right? The text generated, the knowledge retrieved, and of course, the original input, so as to generate this kind of a solution. Okay. And then the answer generator, of course, will basically, it's a rule-based stuff, which essentially just tries to figure out what is the matching answer in the solution which is generated. Okay. So here's a third example. Essentially this is about some which animal skin is adapted for survival in cold places, and the Chameleon framework nicely recognizes that it must do image captioning and then do Bing search by first doing a query generation, and then after taking all of those outputs, generate a solution and then come up with the final answer. So as you look at it, Chameleon basically takes the image input and uses LLMs so as to generate a sequence of tools and to be used to generate the answer. And all of these tools are primarily essentially just LLM prompts themselves. Okay. So image caption is basically going to be just another image LLM prompt. Knowledge retrieval is also another LLM prompt. Solution generator is an LLM prompt, and so on. Okay. So during each module execution, the module first processes the query and the cached context. Cached context means anything that has been generated so far. Okay. And it returns a result determined by the module itself, what kind of result it should return. Okay. And then it, of course, updates the query. So some of those modules will update the query. Some of those modules are going to update the cached context in that senses. Okay. Here are more examples. I mean, I would request you to pause the video and look at those examples. There are primarily two examples. So essentially, there's an example and these examples are from TableQA kind of things, the question answering on tables. Okay. So some table data in both examples, right? In the first and second. And then there are some questions also. And then the Chameleon framework nicely recognizes that to solve the first example, it requires the sequence of tools. Second example, that sequence of tools. Again, pause the video to see, what those tools do, how they generate the programs and so on. Okay. The entire framework depends on these tools. So it supports several tools from OpenAI, which is knowledge retrieval, query generation, row lookup, column lookup, in case of tables, right? In case of tables, you need those. Table verbalizer. In case of tables, again, you need those, right? But then when it comes to other kinds of tools, Hugging Face, it uses image captioner. GitHub, it basically uses text detector. It's basically a GitHub OCR tool in that sense. For Bing Search, it basically, of course, uses Bing Search API. For a program verifier and program executor, well, I mean, it basically uses Python. So if you really ask, or if you really think about it, these are essentially LLM prompt based, and the remaining ones are actually calling the actual tools themselves, right? Last one, of course, is a rule-based thing, just looks up some presence or absence of certain strings and so on. Okay. So if you think about, so the central controller of this entire Chameleon framework is this planner, right? Let's call the planner as P. And of course, it's a LLM planner. So it basically does the following things. It takes the current query as input. It, of course, takes the planning task instruction as input, the definition of those modules, the corresponding constraints under which those modules should work, and a few demo examples. It takes, so basically, it's a few short LLM prompt which helps you come up with a plan. So there could be a T-length plan, which basically means that you will actually have like T different modules which are generated in the sequence by Chameleon. Okay. Each module execution takes the current input and the cached context. So basically, whatever cached memory you have, whatever things have been generated so far, and actually generates a new output. Now, this output is, of course, going to be fed as input to the next module. Before being fed to the next module, of course, this output is basically combined with the current input, so as to give you the updated input. It can also be combined with the current, cache, so as to update the cache, so that the new, input and the new cache can actually be fed to the next module in the sequence. Okay. Now, this Chameleon framework is basically one of those frameworks which basically augment the large language models with additional, external tools. Of course, several of these, like MMReact, Viper GPT, WizProg are also very similar. They also try to, augment the LLMs with more than 10 tools in that senses. So these are like toolbox definitions. So, they also use GitHub tools or OpenAI tools and Hugging Face tools and Bing tool and so on. So many of them. Yeah. So some of them basically have image processing capabilities, web lookup capabilities, knowledge retrieval, mathematical reasoning capabilities, table reasoning capabilities, and so on. Not everything has everything. So Chameleon is special because it basically supports all of those reasoning with a large toolbox from a diverse set of tools. And it can compose these tools automatically. It can also do natural language planning and can incorporate these tools in a plug-and-play manner. Right? That is what differentiates it from other kind of such approaches. So how does Chameleon perform? Well, they experiment on two different data sets, ScienceQA and TabMWP, which is basically more like table-based question answering, right? And what do you observe? So you observe. So they compare with several methods. Of course, they compare with the baselines like multimodal chain of thought, or GPT-3-based chain of thought, or ChatGPT-based chain of thought, and they observe that Chameleon with the ChatGPT is better than just ChatGPT itself, and also better than chain of thought, right? Also, Chameleon with the GPT-4 is better than GPT-4 with chain of thought itself, right? On ScienceQA. Similarly, on TabMWP, we basically observe that the Chameleon with the GPT-4 is better than GPT-4 with program of thought or even chain of thought, right? And it's basically the best, right? So that's that. Now at the bottom, you see which tools are being used. So for ScienceQA and TabMWP by ChatGPT or GPT-4. Okay. And each of those basically shows whether knowledge retrieval tool is basically called or not, text detector is called or not, image captioner is called or not, query generator is called or not, and Bing search is called or not. Right. So as you observe, of course, on TabMWP, it's basically going to call table verbalizer, which of course is not even used in ScienceQA, right? So that is obvious in some ways. But also what is obvious is in TabMWP, program generator is called so many times, right? So table verbalizer is not called so many times. Well, maybe because most answers don't really require you to generate full answers. I mean, maybe they just require you to choose a few options. Most questions just require you to choose a few options rather than generate full answers. So table verbalizer may not be very important there. But row lookup is used so many times, column lookup not so many times, right? Um, Knowledge retriever is the most frequently used tool in ScienceQA, but program generator is the most frequently used tool in TabMWP. Okay. Here is also a nice automata to show you, how do these program sequences sort of transition across tool usage. So, and this is for ScienceQA. Of course, another similar automata on tab MWP is in the paper. The paper also lists down interesting prompts for each of those tools in that senses, which are LLM based, right? So what do you see here? You basically see that most of these so all of those programs end with answer generator, and that's mandated as well. So they should end with solution generator and answer generator first. And they can start at various places. So they can start with knowledge retrieval, or they can actually start with directly query generation for Bing search. Of course, query generation should happen before Bing search happens. Okay. And then, so therefore this probability is 1, which is good, right? And then you see text generation, text detection basically happens in 30% cases, image captioning happens in 6% cases, and so on. Okay. Okay, so in summary, in this video, I talked about Chameleon, which is a plug-and-play compositional reasoning framework. It augments LLMs with external tools, and essentially also has a planner, which is an LLM-based planner to decide the sequence in which the tools should be used. Okay. They experiment with 2 different datasets, ScienceQA and TabMWP, and they show improvements in the state of the art by huge margins. Okay. Hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.